Thank you for joining. Without further ado, even about 3 years ago, Wi-Fi was still sort of guest access and a few classrooms with Chromebooks, right? But today, wireless is mission critical in K-12, right? Classrooms with 30 Chromebooks, and then if you're a high school or a middle school, you have the, students bringing their own, especially if you're high school, they have their own iPhones and iPads. So we're talking anywhere from, 30 to 70 devices per classroom. And oh, by the way, if Wi-Fi doesn't work, the lesson plans stop, right? Everything happens on Wi-Fi, and so Wi-Fi has never been more mission critical in K-12, and it's sort of exciting and scary. I'm sure it's scary for a few of you, but it's definitely exciting as wireless vendors for us. Now, however, in the last 15 years, and oh, by the way, for the last 15 years, K-12 is the #1 vertical in wireless land, right? So thanks to E-rate over the last 15 years and just market demand in general, Wi-Fi and K-12 have been very synonymous, but we have not evolved the architectures, right? Most of the K-12s that are out there, you guys are still deploying, controller-based architectures, isolated networks, not leveraging the cloud, and definitely not leveraging some of the new age cloud that can dramatically simplify your operational experience, right? So what we're going to talk about today is how are we planning to make K-12 wireless networks brain dead simple. It's really just that, right? I'll tell you my story. I live in a small school district in Northern California, about 5,000 students. September 1st, the superintendent called me a couple of years ago and said, we are having some of the classrooms, only half the kids can get on the wireless network. Consequently, the teachers are not able to run their lesson plans and education has stopped. And, we escalated, blah, blah, blah. October 1st, he said, it's their D-Day. It is not working. You got to do something. So we actually showed up, 7 people from the partner, 4 of us from the vendor, and I was with a different vendor at that time, and then 4 of us from the customer, 15 people. 15 people an entire day, huddled up in the classrooms of the high school, and all our job was to see if we could get 30 laptops at the same time on the network. Like it always happens when you go to the doctor, the disease disappears. For the entire day, we couldn't reproduce the problem. Yet the problem was happening in all the schools in the district, right? So that was frustrating. That was a tipping point for me. 3 days later, I quit that vendor and joined Mist because I felt wireless needs to be more operationally simpler than the current technologies can render, right? So here's the problems you guys are facing and many more, right? In general, people say, I can't get on the network or my wireless sucks, right? My performance is slow, my Chromebooks are not getting on the network. How do I plan my, online testing or digital curriculum? All of this needs a better wireless network and a more operationally simpler one. That's where Mist comes in. We believe fundamentally we've built the best Wi-Fi for K-12, period. That's a bold claim to make. We're a brand new vendor in this space. We have actually deployments in literally starting from Fortune 1 companies, right? We have the world's largest retailer, world's largest online retailer, world's largest social media, world's largest search engine. All of them are deploying their next-gen wireless with Mist. So we're no small company. We're actually built for large networks, right? So we believe for K-12, we are intentionally solving the problem for the next 5 years. If you're buying a wireless network today, you better take a look at Mist, right? So with that, let's go into specifically what is, again, I won't PowerPoint you to death. I'm going to do this maybe for another 3 minutes of slides, and then we'll go into a demo and talk about sort of what all of this means, right? So high density is a thing of the day, every day in K-12, right? It's here and now. I just talked about 30 Chromebooks and then, an additional 30, BYOD devices, and maybe on top of that, some iPads and floating laptops, right? So a classroom in high density in K-12 is high density and is non-controversial. We are the first and only vendor who's actually bringing a 4x4, 4 spatial stream MIMO with a third and listening only radio and we actually have something we call a Bluetooth BLE array for some safety and security functionality in K-12. And we'll talk about all of these use cases in the context of the demo. So again, we took a very modern, fresh look at wireless. Wireless hasn't seen a new architecture in a long time. So this is our endeavor to really take the tenets of a cloud company like a Twitter, like a LinkedIn, like an Amazon, take their back-end cloud and build a highly scalable, easily monitored and managed wireless network. Last but not least, I'll give you a simple, profound use case for the Bluetooth low energy built into this AP. We had an emergency, a shooter on campus incident at one of the neighboring districts of one of our customers. When that happens, there's a lot of panic, obviously, for all the right reasons. But the administration, law enforcement, and parents, all in one voice, wanted to know where the kids are, where the teachers are, and when there is a lockdown happen, they just wanted to know, who is affected and what is going on. How do we know where students are, where faculty are, where administrators are? And, one of these districts, the parents voted for this, right, to give BLE badges to the kids to be able to know exactly where they're on campus, right? It's not about, monitoring their movements. It's about safety and security, right? So we can enable that. We're the first vendor that can actually enable high accuracy location built into the wireless because we use Bluetooth low energy. The student experience on campus is critical. From third grade on, people are starting to tweet now, right? So how do you make sure, hashtag your school district Wi-Fi doesn't suck, or, how do you make sure, there isn't a lingering notion that, man, the wireless only works half the time, right? And so, you don't want your teachers believing that. You don't want your administrators believing that. So you want to make sure you're offering an experience that is seamless. Obviously, you all know when IT does a good job, nobody cares. But when the phone is not ringing is when you've done a good job, and that's our job to help you do that. Now, lots of interesting use cases. Once you add the notion of, I have a school district in Texas, they have 400 entrances, doors that let them into the high school. One high school, 400 doors. They always have this issue of, when parents come in and are trying to, go somewhere, they can't navigate them. Wouldn't it be nice to have the wireless network have built-in Bluetooth and provide built-in navigation? We will provide you a mobile app for high schools or for schools in general if you want to enable navigation, right? So it's built into the product, and we can enable you with that. Again, if you have high school stadiums, and most of you do, wouldn't it be nice if you could monetize for the Boosters Club, using advertising a little bit, electronic, not just the, signs on the walls and signs on the fences, but could you augment that experience without killing yourself and, twitching every time, a game happens and your phone's going to ring off the hook, right? So how do you enable a simpler, better engagement experience in the school, in the high school stadium? You could do that with Mist. Last but not least, it's all about you. The people that showed up on this webinar, 100% of you are IT guys who really are trying to solve only two problems, right? How do I make sure everybody can connect and everybody has a great experience? It's really that simple. Wireless is either people can't connect or it is slow, the video isn't loading, all that kind of stuff, right? So how do we make those two things easier, simpler for you to manage? That's our charter today. I'm done. That's really, again, I have a bunch more slides, but I'm not going to go into sort of the story of Mist and the story of the industry. All I want to say is we are excited because the industry has recognized us as one of the coolest startup, hottest startup, the biggest vendor to watch. And as I told you, in the Fortune 100 space, people are taking notice. We've been in production deployments in 2 Fortune 25 companies for almost 9 months now. So we're excited. Now, with that, let's go into a demo. That's the two of us. Very good. Where's my demo? There it is. Okay. Can you see the demo?
Yep.
Yeah. Okay. Cool. So this is the dashboard. Again, some of you may have already seen it if the local Mist-friendly sales rep has seen you on site or over the WebEx. But if you're not, this is the work of about, say, 9 months of really intense, requirement gathering and we going after, how do we make the wireless operation experience simpler? So let me start with the story I always tell is the CIO of a very, very large retailer. We did about, when I was with my previous vendor, did about 35,000 AP deployment with them. So it was a celebration dinner, and he walked up and said, "Sudhir, great job. 35,000 APs deployed, everybody's high-fiving." Monday morning, when my first consumer walks in, how do I know their website isn't taking too long to load? Right? How do I solve, I'm from the city of Mountain House in NorCal. How do I make sure Lammertsville Unified School District, every teacher, every user is getting the experience we committed to them, right? Because it's mission critical, right? So that's where we said, wouldn't it be nice if we could put quantifiable metrics on the quality of the wireless experience, right? Can we measure it, repeatably measure it, and be able to then compare and go from there, right? So here's an example. Again, I keep going back to, we spoke to the Boingo NOC, we spoke to a bunch of NOCs, right? Large managed service operations teams. And we said, what are the top reasons people call you for wireless problems, right? Again, in school districts, spoke to some of the largest school districts in the country. Why do people call you in the help desk? They say, hey, there are only two reasons people call me. Either they can't connect to the network, or, like the district that I was talking about, where half the kids can't get on the network, or they say wireless sucks, right? Wireless sucks is euphemism for the video is slow, the websites are taking too long to load, enough of them are not able to take the test at the same time, all that kind of stuff, right? So here we're getting down to sort of the metrics of wireless, what is good, what is not good. So here's a simple example, time to connect. If it takes more than 2 seconds to connect to the network, maybe that's not good, right? But I want to know how many people are able to get on the network in under 2 seconds. I could actually change it, right? So it could be more than whatever time you want. You could set that. I could say, hey, I want everybody in the district to get better than neg 70 dBm. You guys are deploying an AP in every classroom. If there's an AP in every classroom, nobody should ever get worse than neg 70 dBm. Why are they getting that? And is there sticky ROM problems, high density problems? We're going to go through that. Capacity. I want to make sure this is one of the most fundamental things we never actually measured as an industry. How much available capacity exists when the school is fully up and running? Do you know? I mean, is the wireless at the brink of breaking apart, or is actually there's so much room to grow? It's time to breathe, right? So we want to monitor capacity. And last but not least is throughput. You all have the pipes you have on your vans, depending on the elementary, middle, or high schools. You have what you have. Is it enough that that you could run, your smarter balance tests, as an example, in California, or whatever test your particular state is running? Could you run that district-wide, if we needed to, right? So we have an assessment on throughput and say, hey, we want to know predictive how much available throughput you have, right? So with that, let's dive into. So, what is the top problems on your network? If you basically said, hey, it's taking only 62% of my users are connecting in under 2 seconds, why? What's happening with the remaining 38 guys, right? So here it's telling me, hey, it's predominantly, it's either DHCP is slow to respond, or, my WAN, so my, either it's the gateway or the WAN or something is slow to respond, right? So now, once I know what my average time to connect is, what my predictive average throughput is per user, and then coverage. This is the per user per minute. Every user, every minute, the average coverage in our network, in our office here. This is an incredible number, never been done in the industry, right? And this gives you a real-time site assessment for your elementary schools, for your middle schools, for your high schools. So when you compare, hey, when it is back to school night, Did wireless go to hell? I mean, did it hold up okay? When there's 1,000 more people, if your school has 800 kids and now 1,000 parents showed up on campus, how does wireless actually live up to it, right? So you can now measure and monitor that. So then let's dive into, okay, why is my average time to connect 6.3 seconds? Then I can dive into what is actually happening, right? So, here it's saying, today, 16 or 12 out of the 48 users in our network actually were taking too long to connect. Well, is it because of DHCP? Well, 3 of them, it's because of DHCP. Well, for the 3 of those guys, what was happening, right? Were they getting DHCP NAC? Were they getting DHCP unresponsive? Here's what this screen is telling you and doing for you. When somebody calls help desk, the first question is it the network? Is it the device? Did he enter the wrong password? Is it the WAN that is saturated? Wouldn't it be nice that help desk could segment those things for you so that not every problem is a wireless problem, right? Many of you are probably one-person shops that run routing, switching, wireless WAN, content filtering and everything. And maybe some of you are not. For the larger districts, there's a wireless specialist or whatever. Either way, wouldn't it be nice to start with where is the root cause of the problem instead of, man, wireless, can't connect to the network. Maybe it's your DHCP server that's out of IP addresses, right? That segmentation, I'll tell you, in Northern California, and Dax knows this, he's from that area, a very, very world-renowned university. They have 5,000 APs. When somebody calls help desk today, they figuratively hang up on them because they say, oh yeah, we know there's problems on wireless problems on this campus. We stopped taking help desk tickets. Why? Because every problem is escalated to the wireless team, and they just can't handle it. They can't debug it, right? So now that is the type of segmentation this helps you do. Let's go down into, okay, great. I have 12 users that had time to connect issues. Do you know who they are? Well, we know who they are, right? So now the question is, once you know who they are, you know exactly which classrooms are having issues, which schools are having issues, right? So you can get down very quickly to exactly where your problems are, instead of saying, Bethany Elementary School has an issue and that teacher is always complaining. Well, now you know, is it because her class has a broken AP? Or maybe her class, all the students in that class are connecting to the neighboring classes and consequently are not in good coverage. You now have that power to segment not just at the network level, but at the end user level, what is that particular teacher's issues. Wouldn't it be nice to have this for your school right now? Right? I'm sure each one of you have these persistently problematic labs or classrooms or Chromebook cards or whatever. When they roll into a particular classroom, like 29 out of the 32 get on the network. And for those 3 students, they're sharing their Chromebook for that period, right? And it's just painful, right? This helps you segment that. Now, once I know, let's say it's time to connect, and say 6% of them are having authorization issues. Coincidentally, Ricardo's iPhone's having some issues. So now, what could you do? What is our current modus operandi? Say, man, Ricardo's iPhone always has a problem, right? So what do you do today? You drive to that school. Hopefully you can find Ricardo, and then you say, hey, dude, man, let's walk the classroom again. Why does your phone always have trouble, right? And by the way, when you do that, I'm going to do a sniffer capture, right? Instead, wouldn't it be nice to say, hey, exactly what was going on with Ricardo's association and connection today? And, we monitor 109 different states for every single connection, right? So, so basically, the idea is there is one way to connect to the wireless network. You associate, authenticate DHCP and DNS, and you're off to the races. But there's 109 different ways you can fail. You could fail in DHCP. You could fail because you got your roaming failed, your fast roaming failed, your MAC authentication failed. A million things. 109 ways you can fail. Right? So historically, wireless never exposed this kind of data for IT to be able to actually quickly get down to what the hell is the problem, right? And so, but here, you could quickly say, hey, Ricardo's iPhone connection failed today because, there was no response from the DHCP server. That's pretty cool. And oh, by the way, how about we take this to the next level and say, I now have a packet capture because we identified that as a catastrophic failure. I have a packet capture, and I didn't even know Ricardo's iPhone is going to have a problem, right? You don't have to know. There's actually a few other ancillary things, right? One of the things is, okay, when he was doing the DHCP request, when that client did a DHCP request, what was the RSSI on that packet? Maybe it was just pure coverage issue. Right here, you could see, hey, he was at neg 84 RSSI, really bad. Nothing good in wireless is going to happen if you're at neg 84 RSSI anyway, right? So here you could go into the packet capture, and now you can actually see, here we've captured the entire transaction. And oh, by the way, you didn't set up traces. You didn't even know his MAC address to do this, right? So now you actually have this essential network rewind, proactive network rewind on a user that you didn't even know was going to have an issue, right? So this is the power of the modern cloud. Only in the new age cloud can somebody do this kind of stuff, because the architecture has to align to itself, right? The architecture has to render this. We have incredible optimization in what we send from the AP to the cloud, yet we send you exactly what you need, right? Because again, we know in K-12 networks, there's tremendous stress on the WAN bandwidth from each of these schools, and so we've built an architecture where in less than 3 packets, I would have sent the entire dynamic packet capture right there, right? So that's the patent that we have as to how we're able to do that, right? So again, very, very granular ability to monitor and manage, right? So let's go back to Mary Kate. Any questions? Anything I should pause, or should we keep going?
I think you should keep going. I would talk a little bit, though, about the applications that you can see. Because one of the questions I always hear from school districts is, I'm trying to get on the testing site. Is it us or is it them?
Fair enough. Very good. Good question. And I'll address that. So again, same thing is, once I know where I segment these problems, and I know who they are, right? So let's say Sunalini's iPhone has some issues. Now let's look at the applications she was running, right? So she was, going to Yahoo Mail, Amazon and Amazon Web Services, whatever, right? So we can see the applications on a per client basis, per AP basis at the network level, and be able to get to, is it the applications that they're having problem. Now, we take it one step further, right? So when I know, these users are having an issues, I could go into what applications, somebody at our office is doing Snapchat, what applications are actually being used when the problems were happening. This is actually interesting. This is sort of ships in the night data, but very interesting, relevant data, right? So when the particular time to connect issues and DHCP issues were happening, what applications were in use. And this is particularly interesting in the case of coverage. What applications were being used most when I counted bad coverage minutes. This is cool, right? This is again, the data always existed problem. Data always existed, just nobody put it all together for IT, and you all had to do manual math magic to put all of this together, right? That's the power of the modern cloud. And so now another really, really, really cool thing that you can see with our system is what devices are suffering most, right? So, again, in here, this is saying, I wish I could show you some of the large networks we have deployed out there. The data becomes very real, very rapidly. What you're seeing here is what device types are in use, which device types had coverage issues, and then, how much of it happened on the iPhone. For example, this column adds up to 100%, right? And so that means 29% of the issues happened on iPhone. 29% of the time when we counted bad coverage, it happened on iPhones. What this is telling you right here is the iPhones are sticky, right? Sticky roaming, and they're just stuck on bad APs. That's not good. Now, then you could say, hey, what is this one? This is 29% of the time on any given, on just the iPhone devices, 30% of them had issues. That's not good. That's way too high. And that's why we are throwing a big red bar here saying that is way above average. Maybe some of the iPhones are old and they're skewing this, but that's anomalous. The Macs are not having any issues. The Apple TVs and Apple Watches are doing okay, right? So then, let me go time to connect. Again, we segment this by every vector, right? And here, which types of devices are taking too long to connect, right? And so what this is doing here is the iPods are taking too long to connect. The Apple Watches, are taking too long to connect, right? I mean, these things are real. Students are wearing them now, the Fitbits and all these types of things, and now you have to support them, right? And so now you could say, hey, the Apple Watch is 2.7 times more anomalous than the rest of the network, right? So typically, in our experience, for time to connect, the Androids particularly haven't done well in most of our large networks, but this is our network. This is real. This is again, one of those machine learning things that you could do all this math yourself. You could pull all of this data via API and do it yourself, or you should let Mist do it, right? So, why should you be in the business of data mining? Now, this is probably sort of the, drop the mic metric for me is, you take any one of your school districts, right? You don't buy 2 iPhones. You buy 1,000 iPads, 10,000 Chromebooks, right? Now, at that scale, how do you determine, do you go to the next, Android Lollipop or Marshmallow, or do you wait? How do you know? Let's say you upgraded a school to the next version of the iPhone. Let's say you have iPads in your elementary school districts, right? You have iPads, and let's say you have 3 of these school districts, and let's say you have 2,000 iPads. And let's say you said, hey, I'm going to do this, one classroom at a time or one school at a time. Let's just keep it simple. Let's say you upgraded, my kid goes to Bethany Elementary, so let's say I upgraded Bethany Elementary, all the 800 iPads have been updated. Now you have a metric that you can compare. Did iOS 10.2.1, is it actually better than iOS 10.2? Historically, how did you used to do this? How did we all used to do this? We would go around and ask the teachers, is this any better for you? And what would the teacher's answer be? It feels better, but I don't know. I can't tell. It's all perception. There is math behind wireless, and we should use it. And that's what this is, right? Here, quantifiably, we're saying iOS 10.2.1 is better than 10.2. And so, yes, when you go upgrade your next 10,000 iPads, you have a measurable metric to go after, from time to connect to coverage to capacity. We segment all these OSs across all these things, right? And so you want to be able to make sure you are informed in making these decisions, right? Now, all of this sounds great. Now, what this would lead you to is, this is one site. And this is where I wish I had access to a couple of my customer networks. One of our customer networks has, 15 sites, like 15 different schools and stuff like that. They go to this dashboard and it'll say 15 different numbers here, right? And so if all elementary schools are created equal, why should one of them have great coverage and one of them have poor coverage, right? And so that's what would come out here is your ability to now measure and metric across across schools within your own district. And you could go even further. You could say, hey, how many of my schools are having DHCP issues, right? How many of my schools are having authorization issues? You can get down to that level. And if all schools are created equal, I mean, each of your elementary, let's say, have 30 or 40 APs, and middle and high schools have 50 to 70 APs, shouldn't they all perform similarly? Why would they be different? They could be different depending on the neighborhoods. Maybe they're in the middle of a very busy RF neighborhood. That'll be good to know, right? And so anyway, this type of stuff gives you that kind of control and measure. Last but not least, one of my pet peeves in wireless LAN is the vendor, right? So you did everything you wanted to do right, and you followed everything you were told, but then you call the vendor and say, hey, some of my laptops are not, getting on the network. Then you call up the vendor and then you say, hey, what's going on? They say, oh yeah, upgrade to our latest image and it fixes every problem. It is nirvana. How do you know, right? So here what we are giving you with Mist is, if somebody fat fingers a config or changes a config legitimately, if somebody upgrades to the next image, somebody reboots an AP, or radio resource management actually changes your channels to the better. For all of these, we now have a dot here. And what that does tell you is like, hey, if RRM changed my channel, did my coverage become better or worse? It's no more, subjective and controversial whether my next release is good for you or bad for you. So when you call us, and oh, by the way, if we screwed up and we told you to upgrade to an AP image that actually made things worse for you, you don't have to argue with us. Neither will we. The proof is in these metrics, in this baseline metrics, right? And so anyway, this is another, little simple, stupid thing, but we believe wireless should be measurable and metric like this, right? And that's where, we add this. Mary Kate? Yeah. I can talk for hours. I want to make sure.
I think we should probably go into some questions if we have any here.
Okay.
Let's see. So anybody, if you have questions, there's a box there where you can type them in. We'll wait a few minutes here and start answering people.
Okay, very good. And then maybe meantime, I could do a little bit of the location piece. So what does Mist sell actually, right? So Mist sells a cloud service that basically, I'm going to show you. Basically, it's a Wi-Fi cloud service with APs. That's what we do. We actually sell a full stack, access points and cloud service. So what that gives you is an ability to, just plug in APs, manage it in the cloud. No controllers. Controllers are sort of a 15-year-old over-leveraged architecture at this point. We believe for K-12, cloud-based networks are the way to go, and there's many vendors out there. How are we different? So let's say you are a cloud-based vendor or a network that is using a cloud-based vendor today. How are we different? Here's how we are different. We intentionally focus on operational simplicity. You've seen the demo, and that's really very, you don't just make some dashboards with some existing stats to get there. You write data science algorithms. That's what we've done. Machine learning, proactive, correlated analytics is what we are about to make the networks operationally simple, right? That's what we offer. So a cloud that is Wi-Fi with APs that are built in for Wi-Fi and Bluetooth Low Energy. Now, so two services we offer, business critical Wi-Fi, which is what most of you are interested in, but we also offer an additional service, which is, Bluetooth Low Energy based location. There's two ways to use this. You could use this in terms of, You could use this as a navigation app for push notifications that you could deploy. But again, it's sort of hit or miss. In high schools, it's great because everybody has mobile phones. In elementary schools, it's sort of worthless because none of the kids have mobile phones. But you could also use this to track assets or people for security purposes, right? So maybe you want to track all your Chromebooks that these Chromebooks haven't left the building and stuff like that. So now you can do that. So how do we do that? And let me quickly show you this, and then we'll go into the demo.
Yeah, and once you're done showing that, we have a couple questions.
Okay, very good, excellent. So, this AP that you're going to look at, which is a Wi-Fi plus BLE AP, has this 16 antenna BLE array built in. Bluetooth low energy is what BLE is, and what it is it's like GPS. It's just like a GPS satellite signal. We're just beaming signals out. We don't receive anything and process anything. Clients don't connect to us with Bluetooth low energy. Once these signals are out there, the mobile app catches it, and then the Mist Cloud sends a blue dot, just like you have GPS on your phone, but without Google Maps app, it's useless. Without an Apple Maps app, it's useless. Somebody has to consume that GPS signal, so you could use an app. On the flip side, you could also just do listen-only analytics. Here's an example. This is these green dots for us are Bluetooth BLE asset tags. I'll give you an example. We use tags from this particular vendor. You could use any tags. We don't endorse or recommend, but we personally use these tags. And so here's an example of an asset tag that you could give to students or faculty or janitors or law enforcement that you could track where they are. This looks exactly like a badge, but it actually does BLE, RFID, NFC, and has more than a school year's length worth of battery life. If there are high value assets, you could also do these beacons that you tie these to Chromebook carts or Chromebooks in the back, whatever. This is pretty inexpensive asset tag, has 4 years worth of battery life, and BLE based, right? So once I have these, then I could actually track them within the premise. And again, you could think of this as students, teachers, staff, janitors, administrators, or law enforcement. When they come on campus, you know exactly where they are.
This is a perfect question to piggyback on that.
Yeah.
How long do you hold on to the data? There may be personally identifiable student data that they want to make sure is purged after a certain period of time.
Great, very good question. And again, we are deployed in some fairly high security environments, and that's a very common question, right? So number one, we only hold data that is useful for management, right? There's zero user client traffic that's coming to the cloud. We don't track it, we don't get it, we don't have an opportunity to do anything with it. Even the dynamic PCAP that you saw, it's purely headers only. Now, there are two types of storage for us. This high fidelity data that we are looking at, all these analytics, we keep this data for 7 days. And again, if somebody wants to use that data past the 7 days, everything, 100% of what you're seeing in our UI is available via API. You can suck it in and dump it into your own data lake. It's your data at that point. We also track very high-level reports. So as an example, I could actually just get a report, a custom report that I can build, and this data at a higher level, we keep for 3 months, for 90 days. And again, you could get this report emailed to you every night, trigger on it so that exactly what your CIO, your superintendent, or your principals want to see, you could get that data to them every night or every week or whatever it is you want, right? This higher level aggregated data we keep for 90 days. We show in the UI for about 60 days, but and that's it. That's the data we're talking about. There's actually several orders of security built into this. Data at rest and data in transit. What is data in transit? Data in transit is data that goes from the AP to the cloud, which is like the MAC address and the username and blah, blah, blah. That is 100% SSL encrypted. Data at rest. Let's say some guy goes in and steals the particular storage server in Amazon that we've stored your data at. Data at rest is 100% encrypted. So somebody goes in, breaks into an Amazon Web Services, data center, gets the data disk drive, your data is completely encrypted, right? And then there's several levels of obscurity being built into the system that protects the data. So there is no way. First of all, we don't sell this data. Nobody else accesses the data. Every particular individual school district's data is stored with unique keys, and nobody else, if they have somebody else's key, they can't decrypt our data, right? Your data. So anyway, highly secure.
Okay. Next question: what happens if the AP disconnects from the class?
Very good. Very. I think that's especially for having been a controller product manager and a controller architecture with 17 years. I'll tell you that's our number one question in school districts. The network will continue to operate. The APs won't reboot. The APs won't disconnect. Your clients won't disconnect. Your network will continue to operate. The cloud is purely management. Right? There's no inline policy or authentication that the cloud gets involved in. So it'll operate like it's a controller-based architecture. Right.
All right. And then the last one is, can you get access to the cloud using a different AP?
Unfortunately, no. Right. Obviously, it's one of those things that you just made a wireless decision with a vendor, and you would love to get all this kind of visibility on your current network. Unfortunately, we are not built for that today. So we would still like to see if this is of interest to you, if there's maybe a school that's coming up, if you need to add additional APs. This is very plug and play. And so, please, at least give it a shot so that when the next opportunity comes to add a school or buy net new APs, you have an opportunity to try Mist.
And then the only other question that I see on here is there an opportunity to demo the product?
I'm sorry?
To try.
Okay. So we absolutely, if you're interested to try the product, we absolutely will send you gear. Let us know. We don't give away free gear per se, but we do try and buys. You could return it if you don't like it after 60 days or so. But absolutely free and clear, free of charge. You can try the product and put it in production if you want. We don't care. We will support you, and let's just make sure it is right for you. And we have folks all over the country that can come in and physically in-person support your installation. So we are excited. We think this is what K-12 really needs to build sort of the school of the future, to build a network for the future, really as you transition to digitized classrooms, right? So digital classrooms are here, but they're only getting more digital, not less. Right? Imagine the day when you have telepresence in every classroom, when you're doing video from every classroom, bringing in users. Many of you may already be doing that today. Trust me, I have a ton of school districts that today bring in classrooms, 6 students over video into live classrooms. All of this is happening. You got to build a network for the future. You can't be looking in the past with some architectures that are just old and tired.
Okay, I think that's all the questions.
Okay, very good. So again, we sincerely appreciate your participation. If you're listening this recorded, we are sincerely excited about the market opportunity here. We want to prove it to you. We believe fundamentally in earning your business, and we will do everything we can to earn your business. All we ask of you is give us an honest shot to try in a school, in a class, at a high school, at a venue, whatever it is. And oh, by the way, if you're feeling good and if you feel like it, give us your worst school or your worst, wireless coverage issues. We're up for it. We want to go take up that challenge. we're excited for the partnership. We are excited to work with you. Thank you for the time. And Mary Kate, with that, I'll turn it over to you.
If you have any questions, feel free to email info@mist.com, and we hope to talk to you soon. Thank you.
Thank you.